Hi, this is John Call, and I did problem number 4. And that was 3x to the 4 f of x equals 3x to the 4th plus 8x cubed minus 6x squared minus 24x plus 37. And now the directions were to find any critical points or points of inflection and then list them as ordered pairs. So the first thing I want to do, is find f prime of x. I'm doing this because I need to find the zeros of f prime of x, or when it's undefined, these will give me the zeros. So yeah, I'll find f prime of x. 12x to the 3rd plus 24x squared minus 12x, then minus 24, and the 37 goes away. So the critical points are at when f prime of x equals 0 or when it's undefined, but we can just cross off undefined because we know it's a polynomial function, so there's no points where it's going to be undefined at. So next thing I can do here is I can factor out 12. I'll just make it a little easier to factor. And so this 12 doesn't really do anything. But then I set it equal to 0. And then I found the zeros, or it would be this. I factored it. I used a calculator, or Calc, short for calculator, to factor it. And then, I know the zeros were x equals minus 2, x equals minus 1, and x equals 1. So these are critical points. And so I brought them over here, or I'm going to bring them over here, and make the f prime number line. Then f of x, -2, -1, 1. Alright, and all these will be zeros. And now I want to find if it's either negative or positive in between these numbers. So I'm going to plug in different numbers into f prime of x. Like, for example, I can plug in 3 or -3 to find out if it's going to be negative or positive over here. And I'm doing this to find out if it is increasing on f of x or decreasing on f of x. So I can type the equation in my calculator. 12x power 3 plus 24x squared minus 12x minus 24. I'm going to go to the table, and I'm going to pick numbers in between these values to see if it's positive or negative. So I'm going to go -3, -1.5, that's in between -2 and -1, and then 0. So as we can see, when it's -3, y is -96, so we know it's negative there. And then in between -2 and -1, it's positive 7.5. And then in between -1 and 1, we plug in 0, it's negative sign there. And I forgot to do it above 1, so we can do 2 because that's more than 1. And that's positive 144, so that's positive. And then since f prime of x is negative, we know f of x is decreasing And then here it's positive, so it's increasing. Same thing here, decreasing, increasing. So we know this is a minimum. Since it's going like this, it's going to be a point right like that. This is a max. It's going to be going like that. That's what the point's going to look like. And this is another minimum. It's going to look like that. All right, so we found some critical points, and now I want to find point of inflections. So how we're going to find these is we're going to need to find the second derivative and find the zeros of the second derivative, or when it's undefined. So we can figure out the second derivative right now with the power rule. 36x squared plus 48x. I'm using this up here. And then minus 12. And again, we don't need to find where it's undefined because we know it's a polynomial function. So there's going to be no points where it's undefined. So we're going to set it equal to 0. And for this one, oh wait, no, we can factor out a 12 again. Double check my math there. Yeah, I think that's right. And then, so this 12 doesn't really matter because when 12, there's not an x value when it equals 0. So now I think I'm gonna want to use quadratic formula to find out the zeros for this part. Because the zeros for the second derivative, that will tell us the points of inflection. So negative b plus or minus square root of b squared minus 4ac all over 2a. So x equals negative 4 plus or minus 4 squared minus 4 times 3 times negative 1 all over 2a, which is 2 times 3, so that's 6. And then that comes down to negative 4 plus or minus square root of 16 minus 12 plus 12. It's going to be 28 for 6. And I already plugged that in my calculator before. There's going to be 2 values because of the plus or minus. And I got x equals 0.2153. And then x equals negative 1.5486. And now we're going to make this number line for the second derivative to find out exactly where the points of inflection are. Or we know where they are, but let's see. This will tell us where it's concaving down or concaving up. And then fx. I really hope you just saw me do all that. I don't really know. I was focusing on my paper. Okay. So plug in our points. Negative 1.5486 and then 0.2153. We know these are the zeros, and we know they're going to be points of inflection because the zeros of the second derivative tell us where the points of inflection are. And then we're going to do the same thing as we did for the one above. Plugging in values in between these numbers and before and after to see if the second derivative is positive, or where those values are, if it's positive or negative, to see whether it's concaving down or concaving up. So I already did it over here, or I did it before, and I think I plugged in negative 2 and it came out to be a positive number. Then in between I plugged in 0 and it came out to be negative. And over here I plugged in 1 and it was positive. I plugged all these back into the f double prime equation. And then that tells us that it's concaving up here and it's concaving down here because it's negative, positive, and it's concaving up again here because it's positive. And then it asked for a list of our values. What's the word called? I'm blanking right now. Ordered pairs. Okay, yeah. So we're gonna need this, all of our critical points, and all the points of inflection, or the x values. And I'm gonna take those values and plug them back into the original equation, like plug in -2, see what it gets me, and that will give me the ordered pair. So when I plugged in -2 to f of x, I got 45. When I plugged in -1, I got 50. When I plugged in 1, I got 18. And then that was the critical points, or the max and minimums. And then I plugged in my points of inflection for -1.5486. I got 47.321. I know these are points of inflection. And 0.2153, I got 31.641. Well, that's point of inflection. Then we're gonna look at the y values here to determine if it's their to determine the absolute maximum, if they're absolute maximums or minimums. And the highest y value is 50, so we know this is the max, and the lowest y value is 18, so we know this is the minimum, or the absolute minimum. And then -2 is minimum too, but it's not absolute because we figured that out up here. Alright, and this is my final answer. So hopefully you were able to follow my writing there.